What specific problem does the Hermes 3 model aim to solve in the context of large language models, particularly in relation to steerability and user interaction?
The Hermes 3 model specifically aims to enhance steerability and user interaction in large language models by being highly sensitive to system prompts, which allows it to adopt and maintain various. This sensitivity is particularly pronounced in its largest version, the 405B model, enabling coherent multi-turn conversations and dynamic role-playing capabilities. Additionally, Hermes 3 incorporates advanced features such as structured output using XML tags, scratch pads for intermediate processing, and internal monologues for transparent decision-making. The model's training on a diverse dataset, including domain-specific data, further addresses known weaknesses in older models, ensuring high-quality responses tailored to user instructions. Overall, Hermes 3 seeks to provide a more controllable and interactive experience for users, distinguishing itself from traditional models that may refuse instructions on moral grounds.
How does the proposed method, Hermes 3, work? Please illustrate its methodology step by step, including details on the training phases and special tokens utilized.
Hermes 3 operates through a structured methodology that includes two primary training phases: supervised fine-tuning, SFT, and direct preference optimization, DPO. In the SFT phase, Hermes 3 is fine-tuned using the Llama 3.1 models, where the training focuses on instruction response and tool use, utilizing a special ignore value for non-target tokens. The training data is packed into sequences with a target length of 8,192 tokens, achieving 96% efficiency, and is evaluated against a combination of The DPO phase employs a LoRa adapter to optimize the model without requiring both a reference and trained model in GPU memory, using specific hyperparameters for efficient. Throughout both phases, Hermes 3 utilizes special tokens such as less than scratchpad greater than, less than reasoning greater than, and less than inner_monologue greater than, to enhance its.
Can you provide a simple example that showcases the inner workings of the Hermes 3 model? Walk through its core algorithmic steps with this example in mind.
A simple example showcasing the inner workings of the Hermes 3 model could involve generating a code snippet for a Discord chatbot. The process begins with the user providing an instruction, such as, create a simple Discord bot that responds to messages. Hermes 3 utilizes its system prompt to adopt the helpful assistant persona and interprets the instruction. It then engages its advanced capabilities, such as using the less than scratchpad greater than token for intermediate processing, generating an internal monologue to outline the steps needed, and employing the less. Finally, Hermes 3 produces the code snippet while also providing detailed explanations and documentation, demonstrating its proficiency in handling complex tasks and communicating effectively. This example illustrates the model's ability to maintain coherence, utilize structured outputs, and adapt its responses based on the user's request.
What are the theoretical or practical benefits of using Hermes 3 over existing models, specifically discussing improvements in reasoning, creativity, and application versatility?
Hermes 3 offers significant theoretical and practical benefits over existing models, particularly in reasoning, creativity, and application versatility. The model's advanced capabilities include structured output through XML tags, scratch pads for intermediate processing, and internal monologues for transparent decision-making, which in terms of creativity, Hermes 3 excels in maintaining coherent and contextually relevant multi-turn conversations, especially in role-playing scenarios, where it can dynamically. Additionally, the model's extensive training on a diverse dataset, which includes domain-specific data generation, ensures it can effectively handle a wide range of tasks, from coding to creative. Overall, Hermes 3's design prioritizes user steerability and nuanced understanding, setting it apart from traditional models.
How is the Hermes 3 method validated or tested? Please elaborate on the experimental design, datasets used, and the benchmarks or metrics employed to demonstrate its effectiveness.
The Hermes 3 method is validated through a comprehensive evaluation process that includes both supervised fine-tuning, SFT, and direct preference optimization, DPO, phases. The training utilized a meticulously curated dataset comprising approximately 390 million tokens, with a significant portion, 236 million tokens, dedicated to. For experimental design, the models were evaluated using a combination of public benchmarks, including the GPT-4All benchmarks, e.g., ARC, BoolQ, HelloSwag, and additional metrics from the Open LLM leaderboard, such as BBH, Math, and MMLU. The evaluation metrics focused on the model's ability to generate coherent, contextually relevant responses, and their performance in multi-turn conversations, particularly in role. The results from these evaluations demonstrated Hermes 3's state-of-the-art performance and its advanced capabilities in reasoning and creative tasks, confirming its effectiveness as a highly steerable language.
What specific results were achieved with Hermes 3? Can you highlight key performance improvements or impacts made by this model and practical applications or benchmarks?
Hermes 3 achieved state-of-the-art performance among open-weight models on several public benchmarks, demonstrating significant improvements in judgment and reward modeling, which enhances the model's training on a diverse dataset of approximately 390 million tokens, including 270 million output tokens, contributed to its robust performance across various domains. In practical applications, Hermes 3 excels in maintaining coherent multi-turn conversations and dynamically adapting to different personas, making it particularly effective for the model's advanced capabilities, including structured output with XML tags and the use of scratchpads for intermediate processing, further improve its interpretability and problem-solving skill. Overall, Hermes 3's enhancements in reasoning tasks and tool use capabilities position it as a valuable tool for complex tasks in software development and beyond.